Okay, so okay, we're going to go ahead and get started. So I only have 6 people connected, so I hope if you're not able to get on there, you follow along anyway. And I can see your responses, so. So I'm seeing that people are missing this because, let me show you. Log 1 over 100. That's the same thing as log 10 to the negative second, right? So that would just be negative 2. It's also the same thing as log 0.01. And if you count the decimals, that would be 2 places past the decimal. So it should be negative 2. Okay. The domain and range for ln x. And if you think about what all log functions look like, if you can think about what all log functions look like, this should okay. So if you think about what the exponential function looks like, and e to the power looks just like, they all go through, pass through the point 0, 1. The parent does, no matter what. Like if you have 2 to the x, 3 to the x, 4 to the x, 5 to the x, 6 to the x, a million to the x, 1/2 to the x, they always are going to pass through 0, 1. And the horizontal asymptote will always be y equals to 0. So for the exponential function, the domain is all real numbers, and the range is the y values that are greater than 0. So for the logarithmic function, you switch the x and the y. So all logarithmic functions, regardless of the base, unless they're being transformed, will pass through 1, 0, and they'll have a vertical asymptote at x equals to 0. So the domain should be all x values greater than 0, and the range will be all real numbers. So think of what an ln and an e do to each other, and y'all are getting this totally right. So that's good, great. So an ln and an e are each other's inverse, so they just cancel each other out, and you're just left with the number 1. Y'all are all getting that. People that are responding are getting it. Y'all are all over the place here. So remember that log base anything 1 is 0. No, it doesn't matter what the base is, because if you think about it, if you take anything to the 0 power, what do you get? You get the number 1. So log base anything, and this is just log base 10 is 0. Log base 10 1 is 0, because anything to the 0 power is 1. This becomes particularly important. You know this kind of stuff when you're solving equations, which Matt will do. It will be the last lesson for the whole semester. Okay, so we're all over the place here too. So what you have to remember is you cannot take the log of 0. What other numbers can't you take the log of? If you think about it. Can't take the log of any negative numbers either. So log of 0 is undefined. And if you have a calculator, if you try to plug in log 0, it'll just laugh at you. So you'll be able to figure that out. Which of these statements is true? So if you think about this, what is log 10? Remember, if it's just written with a log, you know that it's base 10. So log 10, you just count the zeros. If it's a power of 10, would be 1. A log and a 10 cancel each other out, and you just left with 1. ln e and ln and an e also undo each other, and you're just left with 1, because ln is just log base e. Then any log, regardless of the base of 1, is always 0. So A would be true. Log 10 and ln e are both 1. And B would be true because log 1 and ln1 are both 0. So it would be A and B, but not C, because log 1 is 0 and ln E is 1, so they don't equal to each other. You should be able to convert an exponential into a logarithm, even though when you're solving, like in next week when we start doing this, there are other ways to solve the problems rather than rearranging it like this. But you should know how to write the logarithm given the exponential. I've had too much coffee this morning. I'm kind of jittery for some reason. Okay. So if you think about what this means that the exponent that turns E into 1.75 is 0.56. It's always going to equal to the exponent because a logarithm is an exponent. So this would be log the exponent that turns E into 1.75 is 0.56, but we don't write log base E. We write ln, natural log. So it would be ln 1.7 equals 0.56. I'm just a little bit discouraged on some of these because so many people are missing them. You can never take the log of what kind of number. And it might make you feel good that I can't see who's missing them. All I can see is all the responses. I can't see who's getting them right and who's not. Okay, so it is, you can't, like if you take the log of a fraction, let's say just 1/2, that is going to be, this is like 10 to some power equals to 1/2, or whatever your base is, and that's fine. And you can take the log of an irrational number like pi. That would be just like saying 7 to some value is equal to pi. But you cannot take the log of a negative number. That's not defined. So if I asked you to take the log of -7, you'd say that's not defined. But if you're taking like the log base 5 of, I'm just going to make it 5 to the -2, that's a number raised to a negative power, and that would just be -2. So it's okay to have a negative power. You just can't take the log of a negative number. Also can't take the log of 0. Good, y'all are getting this. Good. So all logarithmic functions, if they're not transformed, will have the same general shape. They might be steeper, they might be narrower, I don't know, stretched further apart, but they're always going to pass through the number 1, 0 and have a vertical asymptote of x equals 0. Always. No matter what form of log, no matter what the base is. They always look basically the same. They just might be stretched or condensed according to what the number is, but the basic shape is the same. Okay, here we are. This is what we covered yesterday. These are the laws of logs. Super important that you know these. Okay, we're all over the place here. So make sure that you take some time to memorize these. So the log of A plus the log of B is the log of A times B. And you should know backwards and forwards. So if you're given the log of A times B, you should know that that expands to the log of A plus the log of B. If you're given the log of A plus the log of B, you should know that that condenses down to log AB as a single log. Y'all are getting this one good. So the log of A minus the log of B is the same as the log of A divided by B, and vice versa. Know that backwards and forward. Y'all are getting this one. The people that are answering are getting this one, so that's good. B times log A is the same thing as log A to the power of B. Backwards and forwards. Last one. This is the change of basis formula. log base BA. And the reason you want to know that is that what if you're given something like, this, log base 2, 8. Well, you know that that's 3 because 2 to the third equals to 8. But if you're given something like this, log base 3, 19, well, what power would you put 3 to get 19? Who knows? So you'd either want to know the change of basis formula or know how to use a key on the calculator that will also do the same thing for you. Okay, so that was the last slide. So now I want to spend some time, if you'll pull up the, I put it under the notes for today, since we're having a review day. We'll give you these formulas on the test. You just have to know where and how to use them. So the half-life formula is, this is your ending amount. This is A sub 0, we call that A naught or beginning A. That's your beginning amount. The 1/2 is because it's a half-life. The bottom number in the exponent is the half-life that's given in the problem. It's the actual half-life. And the top number is the number of years that's given in the problem. We'll go through that. It's usually years. It could be, it might be something different, but it usually is the time. Okay, so compound interest, this formula, A equals P times 1 plus R over N to the NT. This is our beginning amount, our ending amount. This is the beginning amount. R is the interest rate as a decimal. People forget to change it to a decimal, especially if they give you an interest like 0.7%. People will forget to change that to a decimal. The N in both places is the number of times compounded. And the T is the number of years. So generally speaking, if we say it's compounding daily, that would be 365 days, 365 times a year. If it's compounded quarterly, that would be 4 times a year. What else did they do? Biannually would be twice a year. Weekly would be 52 times a year. Now, the laws of logs, we will not give you on the test. You have to have these memorized. And we just went over these in the pair deck. This one right here is one that we'll be discussing on Monday. And then, of course, the change of basis formula. You don't always have to use the change of basis formula, but you always could if you wanted to. But like on these examples, log 327, you wouldn't need to use that because we know that 3 to the third is 27. So this just would be 3. Log 981, we know that 9 squared equals to 81. So this would be 2. Log 10,000, you just count the zeros 1, 2, 3, 4, because it's a base 10. Here, ln e to the 1/2 and ln and an e always cancel each other out. So you don't always have to use change of basis formula. It's just a helpful tool because you're not always going to have logs that come out to be nice whole numbers. Okay, so what I'm going to do now is I'm going to do an example problem, and then I'm going to want you guys to do a problem just right after it, and I'm going to call on people. Again, just okay. So this first one, f of x equals log 5x plus 15, I'm asking you to find the domain. Remember, what you have to remember here is you can't take the log of 0, and you can't take the log of a negative number. So 5x plus 15 has to be greater than 0. So 5x would have to be greater than 15, and x would have to be greater than 3. So that is the domain. And you could also write it as 3 to infinity. Now, in the exponent, you can have anything. You can have any variable in the exponent. So the domain, if we're talking about an exponent, can be any number. So this would be all real numbers. Okay. So I want you guys to do this second part where it says, now try.
Ms. Watson?
Yes, sir.
I'll go ahead and volunteer for A.
I would love that. Thank you, Timothy.
Awesome. Thank you.
What's A?
I got negative infinity to 3.
Okay, so let's see. So you said 3 minus x is greater than 0. So
Right.
negative x is greater than negative 3. So that means that x would be less than 3. So that's exactly right. Great. All right, and then what about B?
B? Oh, I didn't start B yet. My bad.
If there's a variable in the exponent, it can be anything. Because you could have 2 to the 5th power, you could have 2 to the 1/2 power, you could have 2 to the negative 4 power. You can have anything in the exponent. So if you have a variable in the exponent, the domain is going to be all real numbers.
Ms. Watson, are we allowed to, I'm just asking, when we're writing out the domain on the exam, are we allowed to just put the R? Or just...
You are, absolutely. That
okay,
I have no problem with that.
Awesome. Thank you.
Okay, so on these, remember that if your base here and here are the same, then they are going to undo each other. They're each other's inverse, and you're just left with the exponent, and it's no longer an exponent. It's just a term, a number. If you have an ln and an e right next to each other, the ln and the e undo each other. But in this case, because this is 1 over e to the 4th, it will be negative 4, because ln of 1 over e to the 4th is the same thing as ln e to the negative 4th. And the ln and the e cancel each other out. Here, if you have these two things right next to each other, they're going to cancel each other out. And you're just going to wind up with pi. So here, however you look at this, you could look at 5 to the 0, which is 1, and log of 1 is 0. Or you could just say those two guys cancel each other out, and you get 0. So if your bases are the same, then they just undo each other. And then if you've got a log of a power of 10, this is less than 1. So there's 1, 2, 3, 4. You count the decimals, the numbers past the decimal. And in this case, it would just be -4, because this is the same thing as log of 1 over 10, 100,000, 10,000. Okay, so now I want y'all to try these. And would someone volunteer?
I had a question about A.
Which one?
The problem A. So on that one, wouldn't the argument be the 2x minus 3 and the log wouldn't cancel that out because the 10 would be an exponent?
This one?
Yes, ma'am.
Okay, so the base here is 10, right? Even though it's not written?
Correct.
So they will cancel each other out, right?
I'm not. I thought.
Okay, let me show you why. So here, let's say, so if we were to write this in exponential form, we would say 10 to some power equals to 10 to the log base 10, 2x minus 3. What am I seeing wrong here? Oh, I see, because I see why you're saying that. Matt, do you see? Can you chime in here?
What is being said?
So I was maintaining that 10 to the power of log 2x minus 3 is 2x minus 3. But
okay, I may have read the problem wrong. So I didn't realize that the log 2x minus 3 was an exponent itself. I thought it was straight alongside.
Oh, okay.
Yeah, it's in the.
Yeah.
Okay, that makes more sense now. We're good.
Okay, I'm sorry. Yeah, I was like, I could see the confusion. Okay, so this is an exponent. Yeah, it's hard to see, but that is an exponent. So it would be 2x minus 3.
Gotcha. Okay.
Okay. Thanks, Hunter. Yeah. All right. So as long as I've got you here, Hunter, what's B?
-7.
It is -7, right? Because the log A and the AL cancel out. And because it's a fraction, that's going to be -7. And ln1?
Zero.
It doesn't matter what base you have. If it's got a 1, log base anything 1 is always 0. And ln e to the 10th?
10.
10. And e to the ln 3x?
3x.
Yeah.
I was daydreaming about the script letters. I don't know.
I do that. I mean, I do that when you're teaching too.
I don't know if we went over
what?
The
all right, just make sure you can you can use your calculator. So I want everyone right now, and this is a power right here. I want everyone right now to make sure that you know how to use your calculator. And make sure that you're getting the same thing I am getting on these. Do not wait till the last minute to realize you don't know how to use your calculator. Calculator is only as smart as the person that is navigating it.
Have we talked about the different script letters?
The different what?
The different script letters for like.
Oh, as far as,
numbers?
I think all I've done is the real numbers.
Yeah.
Um,
The integers
The
are
integers-
Z
yeah,
script.
I love the integers. So integers is the real numbers is that pretty double-sided R, and the integers is a Z with a double.
You know where
right
that's
here.
coming from? Why they do Z for integers? It comes from the German influence from Zahl, or Zahlen means numbers.
I never knew that. I always wondered that. I was like, where's that Z coming from? Because the natural numbers is just N.
Mm-hmm.
And then what else? The whole numbers is just W.
All the rest are pretty
Yeah.
pretty the same. It's like the integers are the really weird ones. Like, why is
Yeah.
it Z? Yeah, and complex numbers are the C script.
Oh, I didn't know that either.
Yeah, there's like an extra little,
Right.
like a little crescent little thing. Yeah.
Something like that. Okay. All right. So does someone think they got all these right?
I think so.
Elliot? Did you
The
get
first one?
What's the first one?
Well, in the calculator, I got 5,280.
Great. What about the second one? Did you get the second one, Elliot?
Oh, my bad. That goes in the calculator, right?
Yeah.
I didn't put it in the calculator.
Okay.
Yeah, but I think I could tell you the number
Okay.
C.
Okay, what's C?
Would that be wait, wait, my bad. Actually, I do not know what C is.
It sounded like you did. You sounded like you're fixing to say it.
Yeah. I'm putting in the calculator, but
How are you putting it in the calculator?
like 4 to the power of like 3.
Okay, so
I'm trying to get 99, but
yeah, you know what? That's really good. I like that. But remember, so 4 to the third power is very close, actually. So you have great estimation skills, but we want it more exact than that. So remember that the change of basis formula is the log of this number divided by the log of this number. So if you take the log of 99 divided by the log of 4, you wind up with 3.3. All right, and then B, you just plug it straight in the calculator, ln 3.5 divided by log 3.5. As long as you know where those buttons are in your calculator, you should have gotten about 2.3. Okay, so then on this one, when we look at the table, and I'm telling you that these are exponential, so you don't have to guess about that. To find the C is always the y-intercept. So we're looking at this. So the y-intercept would be 2. And then the A is the ratio, or the number that you multiply one number by in order to get to the next number. So like if I take the number 6 and divide it by 2, that would give me 3. If I take 18 divided by 6, that would give me 3. And since I know this is exponential, I don't have to prove it to myself. So I know my A is 3. So the equation for this first function would be f of x is equal to 2 times 3 to the x. Okay, so this one, I'm giving you the graph, and we can easily see that C is the y-intercept, which is 3. But now let's see what's our A going to be. Okay, so here I have 0, 3, and here I have 1, 1, and the y values are what we're looking at. So if I was to put this like a table, I would have 0, 1, and I would have 3, 1. So what is my A? It would be this number divided by that number. That's my A. The thing that people miss on this is they want to say it's 3, but it's not 3, because it is the fraction, it's going downward. So it can't be a positive 3 because it's decreasing. So this is going to be 3 times 1/3 to the x. Okay, so I want y'all to do these two. Okay, so does can anyone volunteer to do A? Gabby?
I don't know.
Okay,
so it's A equals 4.
So that's our C is 4. That's the C is always the y-intercept. And then the R or the A is always, if you take any number in the chart, any y value, and divide by the one right before it, because I've told you that these are exponential. So you don't have to guess, you don't have to prove it to yourself. You don't have to. So if I take any number like the number 1 and divide it by 2, what would my A be?
2.
1/2, right? It's because 1 divided by 2, 2 divided by 4. So you take any number in the chart and divide by the one right before it, and that'll give you your A. So this would be f of x equals to 4 times 1/2 to the x. Bree, how about B? Olivia?
I'm not really.
Okay, so
but
what is the y-intercept on B?
looks like it's 3.
Actually, I know this is kind of a crappy graph, but this is 4, right?
Oh,
1, 2.
okay.
Okay, that's okay. I know I didn't put grids on here, so.
Oh no, I see it now. Sorry.
Okay, so C is 4. And then A, if you name 2 points, we've already named 1. And what does this one look like? This second one, what's the point there?
8, 1, I think. Or
1, 8,
8.
right? Yeah, yeah, that's 1, 8. Okay, so if we were to look at it like it was in a table, it would look like the x's are 0 and 1. And the y values are, and we're going from left to right. So 0 and 1, and the y values are 4 and 8. And to determine what the a is, you're going to take any number, any y value, and divide by the previous y value. So what would your a be?
Of the previous y value. So we wouldn't just plug it into the f of x equals 4 1/2 to the x.
Okay, so it's not going to be 1/2, so it's going to be 8 divided by 4, right?
Mm-hmm.
So it's going to be 2.
So it would be 2, yeah.
Yes. And another way that you can tell if it's decreasing like it was in this example, it will be a fraction. It will be like 1/3 or 1/4 or whatever. If it's increasing, it's going to be the whole number. Okay. So then on number 4, write as a single log. So a single log means you're going to have the word log with a big blob past it. You should have nothing being multiplied or divided or added or subtracted. You should just have one word log and then a big blob of stuff. So in this case, this 2/3 can come right here, and we can put it on the y. So that would be ln y to the 2/3. This 4 can be put on the x. So that's minus ln x to the 4th. And this 1/2 can be put on the z. So that's minus ln z to the 1/2. Okay, now once we have gotten all the exponents taken care of, once we've gotten all the coefficients and we've moved them to exponents, now we're ready to write the log or the ln with the big blob. So I'm just going to write ln blob. And anything that is positive will go in the numerator, and anything that has a negative sign in front of it will go into the denominator. So y to the 2/3 is in the numerator, x to the 4th and z to the 1/2 will go into the denominator. So here, another example. Get rid of the coefficients first by changing them into exponents. So this would be ln x squared minus ln y to the 4th plus ln z to the 1/2. Once you've done that, once you've gotten rid of the coefficients and turned them into exponents, now you're ready for your log of a blob. And anything that's positive will go into the numerator. So this x squared is going to go into the numerator, and the z to the 1/2 will go into the numerator. And anything that has a negative in front of it will go into the denominator. So go ahead and try these. And I don't know why I made them different because I'm good. But you should be able to do these. It's a little bit more simplifying on the ones I gave you. Okay. Can someone do the first one? Want to volunteer? Hunter?
Yep.
Would you do it for me? Or talk in steps?
Yes. So first, I combine the first two logs into log 42x divided by 2y cubed. And I move the 3 in front of the second log to an exponent. All right, and then I took the third log and did what you said and just put it in the denominator instead of the more complicated adding another division bar.
Good.
And then I multiplied the bottom to be 14xy cubed.
So 2 to the third is 8, right?
Yeah, I might have done that wrong.
Okay, so yeah, so I know I don't know why I made these harder than the examples, but I did. So if you take 2 to the third, that's going to give you 8y to the third times 7x, right?
Okay. Yeah, I didn't put my 2y in parentheses, so that
yeah. Okay, yeah. That will mess you up for sure. So watch out for that. And then I know that the x's can cancel. So now that's going to give me log 8 goes into 42 6 times.
Yes.
So that 8 cancels with that 42, and we're just left with 7y to the third on the bottom. Okay. Will you walk me through B as well?
Yes. Let's see. So my first step was dividing again, so 25x, and moving the exponents. I do those in one step.
Okay, yeah. So it's going to be log of 25x over what?
5y squared.
5y squared, right?
And then the other 5x is positive, so that goes into the numerator.
Good.
And that'll get you, let's see, where did I put it? Log 125x squared divided by 5y squared.
Okay, watch it again,
Or
because
25.
that's, yes,
Yeah, 25y. Okay.
right, because that square goes with the 5 and the y. And now that's just going to reduce. Okay. You definitely need to be able to do these. All right, now the reverse way is
How did you get 25y again? I was looking at that.
oh, because when you the square goes on the 5 and the y.
Oh, okay. Yeah, I didn't see that for some reason.
Yeah, if there's parentheses, which there should be, that means it goes on. Well, even if there, a lot of times, and I don't like it, I always like to put parentheses, because to me, and the book does this all the time, they'll write like log 5y. The way I read that is log 5 times y, but they really mean the log of 5y. So I like to put the parentheses on there. Okay, so when we're going the other way, we're stretching it out as far as it will go. And for every variable, you're going to have an ln with it. So I'm going to have an ln on the x to the 4th. I'm going to have an ln on the y squared. And I'm going to have an ln on the z to the 3rd. So everywhere you see a variable, you want to spread it out on the same line and put an ln or a log in front of it, depending on which one you're using. Now, if it started in the numerator, it will stay positive. If it started out in the denominator, it will become negative because we're moving backwards. And then the last thing you want to do is put the exponent into the front. Okay, so on this part, this one, again, every variable gets its own ln. Then if it started in the numerator, it's positive. And if it's started in the denominator, it's negative. And the last thing you want to do is change the exponents to coefficients. Okay, so try these. Anyone help me with the first one?
I'll do it.
Beautiful. Thank you. Tell me, go through the steps.
Okay, so first you gotta worry about y3, so do ln y to the power of 3. And since the x and the z is on the bottom, it would be subtraction or negative. Yep. So yeah, log to the power of 5 minus log z to the power of 7.
Good.
And then that's when you move like all the exponents to the front of each
Good.
log.
Great, thank you. And what about this one?
So this time we have two letters that are positive, so we'll do ln z to the power, well there's no power for the z, so you'll leave at that. So then you'll do plus ln x to the power of 4, then minus ln y to the power of 7, and then do the same process of moving the exponents to the front.
And all of these problems had ln's in them, but it's same if log any base has the same properties. So you could do it no matter what the base of the logarithm is. Okay, so suppose you invest, these are application problems. Suppose you invest in a money market account at an annual interest rate of 2.2%. That's not very good. How much money will you have in the account at the end of 8 years if you invest $15,000 compounded monthly? Okay, so we know that if they say compounded monthly, compounded daily, compounded yearly, if they give you an actual amount of compounding going on, then you're going to use the A equals P times 1 plus R over N to the NT, where this is our ending amount, this is our beginning amount, this is our interest rate as a decimal, the number of times compounded, and then T is the number of years. All right, so let's go through and identify everything. So the annual interest rate is 2.2%. So that means my R is going to be 0.022 because I have to change that percent to a decimal. Then it says 8 years. So my T is 8.
Sorry, I don't mean to interrupt, but shouldn't that be 0.22?
So you have 2.2%, right?
Yeah, okay, that would be 20%. Yeah, you're right.
Okay.
You're right. Yeah. It just
No,
threw me off a little
never
bit.
hesitate to stop and ask me because you never know with me. I can
Yeah.
make those kinds of mistakes. So T is 8. Continuing with the problem, we're investing $15,000. So what variable will that go in for? The 15,000. That's the amount you start with. So it's going to be P. And then the number of times it's compounding per year would be how many if it's compounded monthly? $12. So what we're looking for is A. So I'm going to say A is equal to our principal times 1 plus 0.022 divided by the number of times it's compounded to the power of 12 times 8. And then you just plug it in your calculator and you should get a whopping $17,883.69. Now the difference between A and B, and this will be the last one we go over today. And we'll finish these out tomorrow. We'll have time to finish them tomorrow. How much money will you have in an account at the end of 8 years if you invest 15,000 compounded continuously? If you see that word continuously, that means you're going to use the PERT formula. So in this case, again, this is our beginning amount. This is our ending amount. Interest rate as a decimal. And the number of years. Okay, so it's the same problem. We're beginning with $15,000. Our interest rate was 0.022. Our number of years is 8. And we're ready to go. So we'll say A equals to 15,000 times E to the 0.022 times 8. Make sure you know how to use your calculator. And that will give you $17,886.57. This, no matter how many times you compound it, infinitely many times, you'll never get more than this at that interest rate. You can see that this is actually not much less compounded monthly. Where this starts to make a difference is when you start working with really large sums of money. All right, is there any questions? And I will definitely hang on if anyone has anything they want to talk to me about. Otherwise, we will go over the test number 7 tomorrow and continue reviewing this material. And there are practice problems listed on Blackboard under the homework worksheets that are definitely recommended that you do. And memorize those laws of logs. And I'll see you tomorrow.